All right, let's look at the homework 16.8, problem number 3. All right, so let's evaluate this integral using Stokes theorem. All right, so using Stokes theorem, we can rewrite that integral as integral. So it's going to be a double integral over the surface S. Then you have a curl of F, vector F, and the dot product with ds. All right, so let's do that. All right, so first we need to compute the curl. So let's go ahead and do that. So this is going to be a curl of F, which is going to be, we have a vector I, vector J, vector K. Right, so partial with respect to X, partial with respect to Y, and the partial with respect to Z. And the first component is xy. Second component is 2z. And the third component is 5y. Right? So this is going to be equal to, all right, so first component is going to be 5 minus 2. So can I just write 3? All right, second component would be 0 minus 0. So it's going to be actually 0. All right, third component is going to be 0 minus x. So it's going to be negative x. All right, so we have that. All right, then since this is the plane x plus z equals 3, so I'm going to rewrite this guy as solving for z. Z is equal to 3 minus x, right? So we can write the parameterization R as, right, so we can have x and we can have y, and z is just a 3 minus x. All right, so if you want to find the partial of a vector r with respect to x, cross product with the partial of vector r with respect to y would be, all right, so you have a vector I, vector j, vector k. All right, partial with respect to x will be 1 and a 0, and it's going to be negative 1. And it's going to be 0 and a 1 and a 0. Right? So this is going to be, right? So first component is 0 minus negative 1, so it's positive 1. Right? 0 minus 0, so it's actually 0. Third component is 1. All right? All right, so if you do that, then this is going to be equal to, all right, so it's a double integral, right? And let's see, so we have a 3, comma, 0, comma, negative x. And then you have a 1, comma, 0, comma, 1, right? And we have a dA. And over this disk, so it looks like radius is 12 because of 144 is a 12 squared, right? So this is going to be over this disk, I'm going to call it D, right? So let's do that. So this is going to be, right, so we have a double integral. All right, so it's going to be 3, 3 times 1, so 3 minus x, right? Then dA over d, right? So I'm going to use the polar coordinates, so it's right, double integral, right? So it's going to be 3 minus x is r cosine of theta. All right, then we're going to have dA is r dr d theta. And the radius is 12, so r goes from 0 to 12. And then the angle is going to be from 0 to 2 pi. Right? So what you get is going to be, right? So you have a 3 times r, so that has nothing to do with r. So you have, nothing to do with theta. So I'm going to just separate that. So it's going to be integral from 0 to 12. Right? You have a 3r and dr. Then we have, of course, from 0 to 2 pi. And let's see, d theta, right? So that's the first term. And the second term would be minus, so you have r squared, so you have integral of r squared with respect to r from 0 to 12, and multiply by integral of cosine of theta from 0 to 2 pi. Right, d theta, right? So this is going to be, all right, so we're going to get here, we have, let's see, 3r squared over 2, and then you're going from 0 to 12, right? Multiply by, so this is going to be just theta, going from 0 to 2 pi, minus, this is going to be r cubed over 3 from 0 to 12 times antiderivative of cosine is sine of theta going from 0 to 2 pi. All right, so one thing we notice is that since the sine of 2 pi and the sine of 0 is 0, so this guy is actually 0. Which means that we can scratch out the entire second term. So we're just going to get the first term. So this is going to be equal to, right, so you have a 3 times, so r squared is 144 over 2 times, you're going to have, let's see, 2 pi, right? So this is going to be, you can cancel 2 and a 2. And then you're going to get, let's see, 3 times 4 is 12. And 3 times 4 is 12, so 13. So 3 times 1 is 3. So it's going to be 432 pi. All right, so let's check the answer. So I got 432 pi. All right. Let's see, is that what oh, sorry, 432. That's what I said. So 432 pi. All right, so let's check the answer. Submit for testing. All right, I came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.